What if a single voice, one single vocal identity, could speak pretty much any language you throw at it, flawlessly, without losing its unique character? What would that even sound like? Well, you don't have to imagine. Just listen to this.
Okay, so check this out. Here's a sample phrase generated by a brand new AI model. This is the Sophia voice, speaking in English. Like the video and subscribe to the channel.
Now get this, it's the exact same voice identity, saying the exact same thing, but this time in German.
And to complete the trifecta, here it is one more time, same voice, now in Mandarin.
点赞视频并订阅频道。
Pretty wild, right? That was the same core AI voice across 3 totally different languages. So the big question is, how is that even possible?
All right, let's pull back the curtain. What you just heard is the work of Nvidia's new model, and it's called Magpie TTS. It's designed to do exactly this. The model itself is built on 357 million parameters. Now, in the world of giant AIs, that number might not sound massive, but that's actually what makes it so cool. It's incredibly efficient. It's so compact that it can run locally on regular consumer hardware, only needing a little over 3 gigabytes of VRAM. So here's the key takeaway, the main idea you need to grasp. Magpie TTS generates natural-sounding speech from a single English speaker identity, but it can do it across 9 different languages. That vocal consistency, that's the real game changer here. Okay, so that's what it is. But how does it actually work? How does it turn simple text into that seamless, multilingual voice? Let's take a look inside the AI's voice box. You can really think of it as a 3-step process. First, an encoder analyzes the text you give it. Then, a decoder predicts what that text should sound like, but as a set of special audio codes. And finally, a part called a NanoCodec takes those codes and translates them into the final audio waveform that you actually get to hear. And for all you tech folks out there who are curious about what's under the hood, this is all built on Nvidia's powerful NeMo framework. And yes, it's using that state-of-the-art transformer encoder-decoder architecture to make all this magic happen. All right, the theory is cool, but how well does it actually perform in the real world? Let's break down Magpie TTS by the numbers and see what it's really capable of. The scale of this thing is honestly pretty impressive. It supports 9 languages right out of the box. English, Spanish, German, French, Italian, Vietnamese, Mandarin, Hindi, and Japanese. And you get to choose from 5 distinct speaker voices: Sophia, Aria, Jason, Leo, and John. All of this built on a foundation of over 50,000 hours of audio training data. That's a lot of learning. So how good is the quality, really? Well, we can measure it with something called the character error rate, or CER. Just think of it like a typo rate for spoken words. The lower the score, the better. And as you can see, these numbers are crazy low. English is sitting at just 0.34%. That means it's incredibly accurate. Now you're probably thinking, this must be a real headache to set up, right? Nope. In fact, what you're looking at here is pretty much all the Python code you need to get it running. It's just a couple of lines. This makes it super accessible for any developer who wants to start playing with it right away. And what do you get when you run that ridiculously simple code? You get this.
Hello world from NeMo text-to-speech.
Yeah, clean, crisp, high-quality audio straight from the model. Just like that. So this is clearly way more than just a cool tech demo. It has some serious implications. So let's talk about what's next for voice technology. Where does this all go from here? So why does a model like this actually matter? Well, for starters, it's ready for commercial use right now. This could power the next wave of streaming voice agents or allow for speech generation on your devices without even needing an internet connection. The potential for deploying consistent voice experiences on a global scale is just huge. But of course, we gotta have a balanced view. No tech is perfect. Its biggest strength is obviously that consistent, high-quality voice across 9 languages that can run on a hardware you might already have. But it does have its limits. It only supports those 9 languages for now. It doesn't really have emotional expression yet, and there's a 20-second cap on the audio it can generate. It also can't clone a new voice on the fly, what some people call zero-shot capability. All of which leaves us with a final, fascinating question to chew on. If one AI can truly master any language from a single consistent voice, what will our world, our movies, our video games, our digital assistants, what will it all sound like in the very near future?